Welcome to this APO talk. This is Jisoo from Asian Productivity Organization. APO is an intergovernmental organization with 21 member economies in the Asia-Pacific region. It serves as a think tank and provides consultancy to promote innovation-led inclusive productivity. For more information, please explore our website. Today, we're going to discuss the ethics of AI with the resource speaker, Dr. Han Wei. Recently, there have been remarkable developments in AI technologies, and its applications in industry and daily life are becoming common. Governments have also adopted the technology in e-government systems to provide data-driven insights, while supporting problem-solving and decision-making to maximize efficiency and service delivery. However, the question for the use of ethical AI has arisen as an important concern to ensure responsible governance and sustainable interactions with humans. So this P-Talk by Dr. Han Wei will address and discuss how we can design a technical framework that strategically selects the latest advances in AI to build solutions that fit ethical policy requirements. It will also touch upon the Singapore's recently released AI Ethics and Governance Body of Knowledge, a reference document covering the ethical aspects related to the development as well as the deployment of AI technologies. So this P-Talk will conclude with a short interview. Today's speaker, Dr. Han Wei, is Nanyang Assistant Professor, School of Computer Science and Engineering, Nanyang Technological University in Singapore. He was a visiting scholar at the Department of Computer Science and Engineering, Hong Kong University of Science and Technology. Before joining NTU, he worked as an embedded software engineer at Hewlett-Packard in Singapore. And his research focuses on ethical AI, federated machine learning, and their applications in complex collaborative systems like crowdsourcing. His work has been recognized with 17 awards from conferences and journals. So Professor Han, APO is grateful to have your presentation today. So could you please share your presentation?
Okay, thank you. Thank you very much, Jisoo. Thank you very much for your kind introduction. And good afternoon, everyone. For today, I'll be sharing with you some recent developments in the ethics of AI, paying particular attention to policy guidance and principles that we can derive from there to guide our policy making. Okay, so just a brief summary of myself. The basic information is shown here, as Jisoo has just introduced. If you would like to see more of my work, my personal website is shared here. Okay, so for today's agenda, we'll be focusing on three major aspects. The first part, I'll give a brief overview of responsible AI. Nowadays, ethical AI are being called multiple different names. I'll also show several different terms that people commonly use to refer to this concept. And then I will go through a detailed case study of how ethical AI is being applied in one of the e-government applications I have been working on together with our collaborators in China, which is about the fair and explainable AI technology that's been incorporated into smart power grid. Okay, and then for the final portion, I will introduce to you an envisioned way forward about developing ethical AI or responsible AI under the data privacy regulation frameworks, which are emerging from multiple parts of the world, including Europe, including Singapore, and the US. Okay. Let me go through some basic concepts first. So before we talk about the ethical AI, we digress a little bit to talk about some major concepts in the interaction between humans and computers. Okay, so humans and computers, we share some similarities in terms of the major ways of operation. For humans, we sense our environment and process information, try to, through cognitions, make decisions. And then through our other body parts, we can output our decisions, like using our hands to grab something or turn our heads to look at something. Okay, a similar setup on the computer side can be seen here. The computer also has sensors of various kinds that can collect information from its environment. Those sensors can be input devices we are familiar with, like the keyboards and mouses, or other sensors that computers can use to sense more complex environmental conditions like temperature, like vibration, location, etc. The computer also owns a computing system that can perform processing. Various algorithms can be used to do this, artificial intelligence being one of them, to help the computers make decisions. And then the outputs can be displayed for human beings to look at, or be outputted in other formats like controlling robotic arms, etc. Okay? So during the years when people are studying how can we design productive interactions between the humans and the computers, there are golden rules that serve as guidelines for the design of a human-computer interaction. Okay, the 8 golden rules are listed here. Later on, I will also highlight to you why some of them is causing problem with the emergence of the AI. Okay, so for us to develop human-computer interactions that are efficient, that the humans feel comfortable with, we need to comply with these 8 golden rules. Okay, we need to strive for consistency. So across different user interfaces, the similar symbols represent similar meanings, so that people, when they continue to interact with the human-computer interfaces, they can get used to this. They don't have to learn new things all the time. Okay, we got to provide shortcuts for frequent users. So when people start to get familiar with a certain way of interacting with the computers, we should provide them ways to improve the efficiency of usage, improve their productivity. Okay, things like using tabs to scroll through multiple different data entry points, rather than just using mouse that can speed up the operation for familiar users. Okay? We need also to offer informative feedback. When something happens in the computer, we should give the users information that can make it easy for them to understand what's going on. Okay? We don't want to show them detailed error numbers, which are only supposed for internal error checking. We need to show them meaningful messages to say, okay, something has happened. Okay. We also need to provide them with dialogues that yield closure. Okay. For example, if you were to buy something from an e-commerce website online, after you paid for the items, the transaction should tell you the outcome to say, okay, we have received your payments and your delivery is on the way, which yields closure. Okay, so people know, okay, the computer system has correctly received my input. Okay, if without such closure, humans tend to get very worried about whether did something happen, did my order go through, or did they charge my account but didn't capture my order. Okay? So they want this kind of confirmation. And simple error handling. So whenever inevitably there are errors happening in computing systems, we want the error handling process that the humans have to go through to be simple enough, so they don't have to worry about how to correct their operations. Okay? Easy reversal of action. Okay? Sometimes the computing systems are not making errors, but humans may mistakenly perform erroneous operations, which they regret. Okay? So commonly, computing systems would have undo buttons for us to undo our operation, reverse our operation. Okay? We also want to reduce the short-term memory load placed on the users. Okay, we don't want the users have to remember a lot of things that the computers can easily track. Okay, we don't want them to say, okay, but in order to answer this survey question, you need to remember what was your answer for previous questions in another survey. Okay, we want the computing systems who can easily remember this to do this. Okay, and finally, and quite importantly, we want to support what is called internal locus of control. Okay? Internal locus of control means that ideally, the computers should receive the user's instructions first and then act upon these instructions. Whenever the computers are acting without first gaining permission from the user or gaining instruction from the user, then the user tend to get very worried about this. Okay? Okay? So with this background, when we look at the interaction between humans and AI again, we can feel that there's something wrong with the interactions we provide that may cause some conflict concerning the 8 golden rules. Okay, so nowadays AI has profoundly changed the way we work with computers. Okay, we no longer need to issue instructions to passive computing machines and wait for our instructions in order to act. The AI solutions, they are characterized by the level of autonomy they have. They can autonomously decide to perform certain actions, possibly based on some directives given to them by the human designers prior to such actions. But individual actions, they may not need to wait for humans to initiate this. Okay, and we are moving towards a partnership allowing humans and AI agents to achieve individual and collective goals. Okay, so in systems, we have humans playing their part and AIs also playing their part. Taking, for example, something people are familiar, like the Uber system, or the equivalent of system in China, like Didi or Grab in Southeast Asia. In these kind of systems, it's a mixture of between human operators and AI agents acting in such a system. So the AI system often performs the role of matchmaking between the orders and the human drivers. And of course, the human drivers themselves would have to actually carry out these orders by driving the customers from point A to point B. Okay? So in such a system, neither the agents nor the human beings are always in control. Okay? Sometimes the AI may decide to match certain orders to certain cars, but maybe due to the particular situation the driver is facing at that time, the driver may decide to not to take up this order, or the driver may have been delayed somewhere and resulting in him unable to fulfilling this order. Okay? So there's uncertainty, which results in neither party fully in control. And the level of flexibility and continual evolution of collaboration in such an organization is very apparent. You get the AI system pretty much staying in operation all the time, but drivers may come online and go offline to rest in their homes from time to time. And the schedule is very flexible. You can't really anticipate when some drivers may come online, and some drivers may decide to call it a day and stop. Okay? So in that case, we need to motivate actions by incentives rather than dictating. Okay? The AI system, when they are trying to get the human drivers to come online or take certain orders, they will need to resort to incentives rather than direct instructions on what to do. Okay? So you can see here, with the interactions between humans and AIs, one of the 8 golden rules of HCI has been violated, which is the 8th one, so quite an important one, what we call internal locus of control. Okay? And the human AI interaction, the AI has certain level of autonomy, and from the human's perspective, sometimes the AI may do something that's unexpected. Okay? Because for individual human beings, they may not have the entire collection of information that can enable them to make an informed decision. They may not be able to see what's the optimal solution given the situation, where the AI would have possibly better overview in control of the situation. And their actions initiated by the AI, possibly for the collective good, may be very surprising for certain human users. And the loss of internal locus of control is a very well-known factor that can cause discomfort when it comes to human-computer interaction. And this is why we are so worried about AI. Okay? The face of AI could be characterized by something like this, like the Terminator. Whenever the news medias or films that want to incorporate an AI character into their storyline, some sensationalization is often resorted to. It causes a lot of suspicion or discomfort from human users' perspective, human population's perspective. And there are a lot of questions being asked about the ethical application of AI. For example, what happens after the end of jobs? Would AI take over our jobs one day? How do we distribute wealth created by machines if one day only machines are working, no humans are working? Okay? So how do machines affect our behavior and interactions? Okay? How do we keep AI safe from adversaries? So how do we stay in control of such a complex system? Okay, because from the loss of internal locus of control, we are losing control to a certain extent by delegating the autonomy to AI solutions. So how do we eliminate AI biases? Okay? So how can we guard against mistakes made by AI? Would those mistakes be easily reversible, or would AI be able to recognize those are mistakes from the human perspective? So how do we protect against unintended consequences? Okay? And how do we define humane treatment of AI if one day we want to allocate rights to AI systems that are similar to human rights in our today's concept? Okay? So these are some worries about the ethical use of AI, and surely some of those worries from the current perspective is still quite far-fetched, because at the current stage of application of AI, we are not there at that stage yet. But nevertheless, there are valid worries in anticipation of future development of AI that we need to start thinking about earlier on. Okay. So based on this kind of worries, a lot of different frameworks about thinking of the ethical use of AI has emerged. Okay. Companies such as PricewaterhouseCoopers, they have proposed their framework of responsible AI. Other companies, organizations are proposing similar things. From the IEEE, over the past few years, they have been proposing the ethically aligned AI, the ethically aligned design for autonomous and AI systems. And Microsoft also proposed their version of AI for good. And the European Union, they have a consortium also working on trustworthy AI. Okay, although they come in different names, but they refer to a similar collection of concepts that we need to pay attention to when we work on AI solutions. And they can be summarized as, in this figure here. Okay, if we were to talk about responsible AI or ethical AI or other names you prefer to refer to this phenomenon, in order to achieve responsible utilization of AI, we need to work on this 6th dimension of added aspect to our AI solutions. Okay, we need to talk about fairness when we're designing AI solutions. The fairness notion can be very diverse, okay? Based on whether you are analyzing biases in the training data, or we are working on the AI-initiated allocation of resources to people. There can be different variants of the fairness notion that you want to consider. Okay? Currently, it is not really recommended that you try to include as many fairness notions as possible, because some of the definition of fairness may be overlapping or in conflict with each other. Okay? So that requires you to have a very detailed analysis of your own situation to look at what kind of fairness notions your society or the society within which you intend to deploy your AI solution is valued the most. Okay? Transparency and accountability, they are related to how can we explain the functionality of AI. They are related to what people refer to as explainable AI, which is also a very active field of research currently. Okay, so we want to give transparency from different perspectives. We sometimes, because when we are looking at AI solutions, the intelligence of AI is always embedded in the training data. Okay, the intelligence is always in the data. Okay, so we say, okay, we want to use an AI system to predict the, for example, we want to use AI to predict stock price tomorrow. Okay? It is based on the assumption that from some set of data, the knowledge can be extracted. So the information that influences the stock prices you can see tomorrow is assumed to be already embedded somewhere in the data. And the AI model you use to achieve this objective is only trying to extract this data to extract this knowledge efficiently from the data set. Okay? Okay, so depending on what kind of data sets you use, your model would achieve different levels of performance. And of course, we want to understand how the data points that we have selected to train our AI models are affecting the final performance of the AI model. Okay, we want to achieve this kind of transparency. We want to allocate the accountability to different data points within our data set, so we can know, okay, which ones should we keep or which ones should we not pay much attention to in later parts of the training. Okay, so that's one dimension of transparency and accountability. And also, there are other lines of work that is working on analyzing explaining the different components of an AI model to analyze what kind of roles they are playing in terms of the final observed performance of the model. Okay, people are analyzing different parts of a neural network to see, okay, which part of the neural network is really responsible for the kind of recommendations that the model is producing, and can we do something about those parts in order to achieve either less bias in the final output or achieve a higher performance. Okay? There are other aspects that focuses on privacy protection, because nowadays a lot of societies they are getting very worried about the exposure of sensitive information, because nowadays with the ubiquitous deployment of AI systems, ubiquitous utilization of computing systems, people do a lot of things with computers, and we leave behind a long trail of data, which can be used to infer very private events that in our life, which need to be properly controlled. Okay. Other aspects of security is very important. You may have already heard about the news reports on deepfake and people trying to leverage the vulnerabilities of computer vision systems to fool the system into thinking about recognizing certain objects, or trying to generate fake videos about some people performing certain acts. Okay? So these are security aspects that we need to work on to ensure safe usage of AI applications. Okay? Of course, robustness is another dimension that we need to work on. In terms of the training, the robustness can happen in the training process, or training really large models. For example, through privacy-preserving collaborative training, these kind of large models often incur a lot of overhead when transmitting those training parameters across different machines. And we need to see, okay, how can we save in terms of efficiency, while at the same time still achieve good convergence for the model during training. Okay, so all these different aspects, they constitute what we call responsible AI solution development, and they got to be incorporated into the AI design from the start in order for them to take good effect in the final solution. Okay. So in terms of the techniques we can use to develop responsible AI solutions, nowadays, in view of the human agent collective, in which humans are operating together with the agents, there are different concepts being introduced to guide solution development. The concept of flexible autonomy, where AI agents can take actions autonomously without reference to their owners, is one thing. We got to give them different levels of permission for them to act autonomously. We have the human in the loop or man on the loop level of autonomy. This is a very restrictive one. In this kind of situation, every recommendation made by the AI solutions need to be confirmed by the human operator. Okay? So this keeps the human in the decision loop. Okay? We also have the more relaxed version of human over the loop, where the humans only give high-level directives as to what kind of objective the AI solution need to achieve. Then each individual recommendation by the AI systems, they don't have to wait for human approval in order to take effect. Okay? There are also situations where the human is out of the loop. This is also often related to indirect stakeholders of AI solutions. Okay? For example, if we were still to use the Uber example, the traditional taxi drivers, they can be considered human out of the loop because they don't directly use the solution that contains AI component, and yet their livelihood is being affected by the adoption of this new technology. And they may form a kind of societal resistance to the technology, which need the policies to be amended in order to either gain their support for the new technology or protect their interests when the new technology takes over. Okay? Agile teaming is another aspect where multiple agents and the humans join together and disband dynamically. So this is a kind of characteristics of the human agent collective. Okay? With such a characteristics in mind, we need to perform incentive engineering. This is also an area where policies can take effect, but very careful policy decisions need to be made in order to define incentives that really promotes the desired behavior patterns that we want to witness when humans collaborate with AIs. And this is extra challenging because the kind of behavior patterns that are emerging are most of the time what we call emergent behaviors. Okay? They are as a result of complex interactions. Although you have some idea of what kind of emergent behavior you wish to see, the detailed interaction that eventually result in such behavior due to its complexity is very difficult to analyze. So that adds challenges to the incentive engineering part for the policymakers. Okay. Of course, accountable information infrastructure is key for this kind of responsible AI application. They need to provide situational awareness to the humans in the human agent collective, so they understand why certain decisions are being made by the agents, whether this is due to valid reasons or due to poor design in the AI solution. Of course, this kind of information also need to be acquired when protecting data privacy, as this kind of regulation now is very widely adopted. Okay? So in terms of the desirable properties of responsible AI, we wish to witness. We can see we wish humans have agency, and yet at the same time provide oversight. Okay? We wish to see that technical robustness and safety can be achieved for humans for AI solutions. Okay? The privacy and data governance is an important aspect as well. Transparency, diversity, and fair treatment of human beings, and societal well-being as well as accountability. These are dimensions of ethical AI that we wish to achieve. And in order to achieve them, we can map them towards the technical approaches for realizing AI solutions in view of the human-AI interaction environment that is emerging like this. Okay, so to give you a more solid understanding of how we can incorporate ethical considerations into AI solutions, let me show you a case study, which is the Power Intelligent Decision Support System. We recently deployed this system in Shandong province in China in collaboration with our partners in the Shandong University. So they are working in this area for many years, and we're trying to help them to incorporate AI solutions that contain certain desirable behaviors from the responsible AI dimensions. Okay, so this system is set out to address the imbalance in power supply across China, which is quite a geographically large country. Okay? Of course, the power usage over the years are increasing, and at the same time, the generation infrastructure, the capacity development, they will need time to catch up. Okay? So there are situations where there is demand and supply mismatch. And of course, this is exacerbated by transient pressures on the network. Those pressures can come from seasonal changes, can be due to natural disasters that are happening, or can be due to migrations of users. Okay? For example, during Chinese New Year migration, there could be sudden change in terms of the power demand when large populations move from different regions. So all these kind of situations would place pressure on the smart grid system, which need to be addressed. Those changes, those imbalances can be addressed from two dimensions. Either we can address them from the supply side through production scheduling, or we can address them from the demand side through recommending to the customers to schedule their usage patterns. Okay, and those can be we can talk about corporate customers, companies who individual companies who constitute quite large demand on the power side, or we can talk about consumers with household usage, which collectively can also play quite an important role in the power demand. So for this work, I'm going to share you. We focus on managing the demand side of the power requirement, and we particularly focus on the corporate customers, okay, because there are established contractual arrangements with the power generation authorities on managing their utilization pattern when certain disruptions are happening. Okay, so this is how prior to our system, this is the way this situation is managed. Okay, the whole thing can be illustrated in this flow chart. When short-term power consumption disruptions are happening, we need to predict consumption gap in the short term, possibly in 2 weeks' time, and we need to adjust the power consumption plan after the prediction is made, and then we'll get the response to the plan from the participating companies who have a prior arrangement with the power generating authorities, and they would be reviewing these kind of adjustment plans and submitting the plans for approval to the authority. Okay. Finally, once these plans are approved, they will be executed on the predetermined schedule in order to ensure safe operation of the whole grid. Okay. So the AI solution is helping steps 1 and 2, the prediction and the management of adjustment. Okay. Okay. So for the whole system design, since it contains both the prediction part and the decision support part, of course, they have a data collection tier responsible for anticipating, feeding information to the prediction model. Okay, they will also have the modeling layer, which is responsible for short-term load forecasting, and the utility layer is where we are focusing on, which contains the demand response module and the orderly power utilization module. So these two terms refer to different levels of forcefulness in terms of the adjustment of electricity usage patterns based on the different kind of demand and supply imbalance they are facing. Okay? Of course, user interaction tier will provide interactions for different stakeholders involved. Okay? The incorporation of fair and explainable decision support will be focusing on the utility tier. Okay? And without going into much technical details, I can show you some basic approaches that we take to incorporate this part. Okay? So the technology we are using for this part is joint objective optimization, which is a commonly used type of resource allocation algorithm in AI solutions. Okay? So in order to ensure fairness, the problem that we wish to solve is the distribution of benefit or sacrifice among the companies within each round of usage pattern adjustment. Because there are situations where we would ask certain companies to try to scale back their operation in order to reduce power demand for a certain period of time to ensure safe operation, but this kind of action would inevitably resulting in them suffering some production losses. Okay? They will suffer production delays, which will be making sacrifices to us. Okay? So there will be also situations where we would ask certain companies to increase their production, and this could be perceived as a kind of benefit for them, as they can produce, sacrifice their orders, satisfy their orders faster. Okay? So this kind of distribution of benefit and sacrifice need to be properly managed among companies, so we don't unfairly allow certain companies to be benefited or sacrificed repeatedly over time. Okay? And of course, this kind of second consideration is this kind of fluctuation across different time steps when people are making receiving benefits or making sacrifices should also be minimized. Okay? And this whole thing should jointly minimize our economic loss. Okay? So jointly considering the productivity aspect as well as the fairness aspect, we utilize this kind of a framework we propose, where we look at the value of the task that each company is performing, and the prior reputation of those companies in terms of how well they comply with the requests for them to adjust their production plans. And we can estimate the kind of utility gain for allocating certain either scale back or scale up of production to different companies. That part will advise us on the system level utility performance we can achieve. On the other hand, we'll look at the current load in terms of the amount of sacrifice or amount of adjustment we are asking companies to perform versus their productivity, their capacity to accommodate this kind of changes. And we will see whether this kind of changes, which can be quantified with our technique to represent the level of regret facing each company. They are evenly distributed among different companies, both across time and across different companies. And this kind of even distribution of regret would help us estimate the level of fairness, the fair treatment we are giving different companies. Okay? So this kind of framework balances the consideration between achieving productivity versus achieving fair treatment of companies. And naturally, since the resulting recommendations are outputted in the form of rules, they are naturally explainable to an observer of the system. Okay, so this system, you can see there is a screenshot of the user interface shown here. Of course, we translated everything on the user interface into English for you to understand. The actual system, since it's deployed in China, everything is in Chinese. Okay? So it has been deployed since 2018 in Shandong province. Okay? It is helping us managing about 400 companies participating in demand regulation, and over 10,000 companies have signed up to participate in the orderly power utilization operations. So there are different levels of management that the companies can accept, the management recommendations the companies can accept. Okay, so with the advice of this kind of system, compared to previous systems without using PIDS, we can see the time without power disruption has significantly increased from only 48% previously to now 76%. Okay? So 76% of the time, we don't really experience any power disruptions. This is partially due to better prediction models and partially due to the optimization of how to allocate changes in production patterns. Okay? And the percentage of forced power disruption through forced shutdown in the OPU operations, they decreased from 16% of the time to only less than 1% of the time. So this significantly helps us improve the overall productivity. Okay, so the last portion of today's talk, we envision some future development in responsible AI. Okay, so currently there's a major trend of development which focuses on protecting data privacy and user confidentiality. Okay, so traditional machine learning would require us to move all the data to our models. Okay, we need to aggregate training data and feed them into our models, like in this cartoon showing how we feed the sheep. Okay, in this process, inevitably data privacy is violated because we got to make copies of the data from their original owners to a new location, and this would become unacceptable in the GDPR regulation and other data privacy regulations. So federated learning has been proposed as an alternative solution to this. The basic concept is that we will move model training to where data have been generated originally, and nothing other than the model itself will leave the different data silos. So in this way, we don't have to expose the private data to any third party and while we're training our machine learning models. Okay, so this field has witnessed a very rapid development in the recent years as companies realize how important they are, and they are under different arrangements based on the application scenarios facing them. So we can have scenarios where different data owners, they're coming from the same domain, meaning that the data are of the same format, but they may be about different users. Okay, for example, in this situation, we may have several hospitals trying to come together to train a model that can help them improve diagnostic accuracy. In this case, the data format across different models are all the same or pretty similar. Okay, and they're about different patients. Okay, of course, under data privacy protection laws, no hospital would be allowed to expose their data to any third party in order for training a useful machine learning model. But with federated learning's help, this can be achieved without exposing private data. And the key idea is like this. Okay, so each data silo hosts data, and they are required to have some local computing power for model training. Okay, the shared model would be initiated into an empty structure, and this initial empty model would be sent to each data silo, and they will utilize the local data to train the model itself. And then after different rounds of training, they will send the local intermediate training results back to the server to be aggregated into an updated model. And then this updated model is then sent back to all devices for further training. And this continues on until the model converges. And when we obtain the final model, it is equivalent as if all the data has been aggregated into one location first, then trained. Okay, and there are other application scenarios as well. We can also handle situations where the different data silos, they come from different business verticals. Okay, they can be a bank, a ride-sharing company, and an e-commerce company trying to train a model collectively together. And of course, they will be about. They can be about. They are about different aspects of our daily life. Okay, the data format will be very different. And if we were facing a situation where all three companies, they serve pretty much the same set of users, okay, they have very large overlap in terms of the users they serve, and we can leverage the common users as a way to transfer information across these different data silos, so they can train a larger model that can analyze these three different aspects of our daily life in this situation to perform certain learning tasks, like, for example, predicting who are credible bank customers based on people's online shopping behavior or ride-sharing behavior. Okay? Of course, if there are more challenging situations where we face data silos from different business verticals, and at the same time, there's a very little overlap in terms of the users the companies serve, then we need to resort to more advanced techniques like federated transfer learning in order to achieve a collective model. Okay? And under this new emerging emphasis on data privacy, if we were to move forward to design responsible AI practice under this domain, we need to spend our effort into developing a new set of technologies that can enable these kind of operations listed here in the presence of data privacy restriction. Okay? So we need, in order to move from data to model, we need new technologies that can perform data valuation without looking at the raw data directly, or without exposing local data and producing such data valuations. Okay? Since now we have different data owners participating into the collective model training, we need to incentivize them for continued participation. That's why we need the contribution assessment to make it accountable who has contributed how much. Okay, again, doing this without looking at the raw data. And we got to design different incentive schemes to persuade them to stay on with the data federation. Those incentives may involve money if we really have such resources to distribute, or for models that are not for profit, we will need to find other non-monetary ways to incentivize participation. Those can be through delivering models with different levels of performance based on the different participants' contribution. Okay, of course, inevitably we'll be facing participants who want to misbehave, who want to abuse the situation. We need to find ways to detect such abuses and put in place punitive measures to deter misbehavior. Okay? And when we are training large models in this manner, we see that we need to move models to data locations quite frequently. If those models are really huge models for industry usage, for example, if we were to say Amazon would want to train a model collectively between their companies in the US and their branches in Europe in compliance with data privacy protection, their models could be huge. And how do we robustly train such huge models? We need new technologies to achieve this. Okay? So this would be an envisioned framework that moving forward we can focus on. And this would provide authorities with new technology tools for them to really perform the required governance. Okay? The image is shown here, so is a public is an image published by the Infocomm Media Authority from Singapore. Okay, they are envisioning a data sharing ecosystem. Okay, possibly built on top of privacy-preserving federated learning as a medium to enable data providers and data consumers to share their resources to build new AI models, and at the same time, the authorities can provide oversight to this whole process. And based on the envisioned framework about responsible AI in a privacy-preserving manner we just talked about, you can envision the different kind of tools that such a framework can produce for the different stakeholders involved in order for them to play their roles. Okay, you could say, okay, for the data providers, we could allow them dynamic federated learning collaboration formation. Okay, we could support the design of different incentives that the data consumers want to put in place in order to attract data providers, high-quality data providers, to join their federations to train particular machine learning models. And the governance side, the government will see a new range of tools that can help them provide their oversight, okay? Such as data valuation and auditing tools that are privacy-preserving in nature, interpretable federated learning training and visualization monitoring, fair participant contribution evaluation, and behavior modeling, as well as misbehavior deterrence optimization tools. So all these tools, of course, they are built on the assumption that they can operate under strict data privacy protection. Okay, so you can see this kind of tools would be very useful for any governance operations to take place. Okay? We can set policies really nice, but without these kind of technical tools, there's no way to really enforce those policies. So this could be something we can envision working forward. Okay? At the final point, I want to come back to the definition of human ethics to highlight how difficult it is for computers to really think about the ethics aspect. Okay? Because for us, even for our human societies, in terms of thinking about ethics, we also face some challenges. This is because of the multi-dimensional nature of the concept of ethics. Okay? You can see here the three main dimensions of ethics are listed here. The consequentialist ethics is relatively easy to understand. They're related to the utility, where we weigh the consequences of different choices we make and try to make those choices that incur the least amount of violation or the most amount of benefit. Okay? There are other dimensions as well for virtual ethics or value-based ethics. Okay? We act and reason according to some moral values we have. And different societies and different people, they may prefer different moral values. This is a very personalized dimension of ethics, depending on how you want other people to perceive you. Do you want other people to perceive you as brave, as just, or some other qualities? Okay? So virtual is highly personal. Deontological or rule-based ethics, they're concerning specific rules put in place as social norms for certain societies to comply or certain groups to comply. Okay? You may have rules that discourage people from speaking, or other rules, other social norms say, okay, in Singapore's case, people need to walk on the, preferably they need to walk on the left side in order not to bump into each other. So there are different societies, there are different rules they can accept. And currently, for AI ethical frameworks, when we're proposing this kind of frameworks, mostly we are focusing on the utility aspect, which for computers are quite easy to compute. And sometimes we've also incorporated some rule-based aspect in terms of social norm modeling, which is also relatively manageable for computers to perform. And for the virtual aspect of ethics, currently it's still quite lacking in terms of the solutions that we can put in place. Okay. So finally, some advertisement of the AI ethics book of body of knowledge. Jisoo, could you please let the technician play the video?
So we're very fortunate to have the opportunity to work with IMDA and to complement their model of governance in AI with our ethics in AI body of knowledge. SCS role in the body of knowledge is to prepare our IT professionals in the certification for ethics in AI. We think that actually, and we believe definitely, that our IT professionals have to be imbued with good AI skills, as well as the ethical use of AI beyond that.
Singapore's approach to AI governance is to support companies' desire to use AI to power their products or to improve the efficiencies of their operations. That is why we put out our AI governance framework that provides very detailed guidance to companies that wish to use data to enhance their products and services, to improve their business operations through the use of AI. The body of knowledge is an important step towards trustworthy AI. The certification of IT professionals will provide business owners who want to adopt the AI governance framework and who want to demonstrate to their customers that they use AI responsibly to be able to have access to a group of professionals who know how to implement trustworthy AI.
Okay, thank you. So finally, Nanyang Technological University has been collaborating with the Singapore Computer Society to put in a graduate level certification program, which trains students on the details of the AI ethics book body of knowledge. So if anyone is interested, I leave the link here. It's a parting gift for today's participants. Thank you very much.
Thank you, Professor Han, for your presentation. Now, let us have a short interview. Due to the time constraints, I think we will have a short interview
Yes,
regarding the ethics of AI. So you explained the principles of responsible, ethical AI, like fairness, transparency, privacy, security, and accountability, and the responsible AI overview that includes flexible autonomy. So actually, this includes like quite comprehensive framework. So considering the points, when designing AI solutions, how can designers organize their thoughts around this topic in an actionable manner?
This is a very important point, because currently this is something that design teams really lack. Okay? So when it comes to software engineering, there's an important step during the initial analysis when people try to identify the objectives the software development team would want to achieve. Okay? So normally they will analyze the requirements from the customers, and they analyze the requirement documentations to try to come up with use cases where they can assign their programmers to do the programming development. Okay? But when it comes to AI ethics, the requirement from the customers are most of the time very vague. Okay? They will say, okay, I want my system to show fair treatment of users. And the team got to start from there to try to understand from the customer's perspective, what does it really mean for this to be translated into actionable development actions. Okay, so for this kind of situations, there are certain design methodologies that current AI solution designers can leverage on. In one of the short courses I teach, I will refer people to the framework based on the envisioning card technology. It's an envisioning card methodology. So the methodology is a design process management tool for teams to brainstorm about solutions, computing solutions that try to incorporate different human values into the process. Okay, they will provide you with the prompting cards for different team members to look at and prompt them to ask questions from different dimensions related to incorporating values into AI solutions. Okay. Built on top of this framework, there is another methodology called judgment call, which is a gamified activity organization methodology for the whole team to play a game where they would try to play different roles of their customers and try to write reviews in anticipation of certain features they are going to develop from the perspective of how well they comply to different dimensions of ethical AI. Okay, so these kind of tools can be a very useful starting point for those teams to use.
Okay, thank you for your answer. And to realize this technology, the adoption in the real life is really important. So this will be the second question. When the new technology is introduced, it takes time to understand the newness and to adopt the new technology in industries and businesses and in our daily life. So have you encountered any issues when trying to convince the industry players to adopt the new technology, like federated learning in their applications, and how did they come out?
Yes, indeed. Okay. We have some attempts in Singapore. We're trying to set up a test bed with the three major banks in Singapore with federated learning. So initially we were trying to convince them to say, okay, can we try to utilize this technology in one of your business sectors, business activities. The one we chose was something like a loan evaluation for small and medium companies. Okay? And the three banks, they didn't respond well. They would say, okay, they didn't want to do this because they gave us something very useful in terms of considerations from their perspective. From our perspective, we mainly focus on how well the technology works. But for them, they would say, okay, if we were to share our data relating to small and medium enterprise loan assessment, once you train this model, you give the same model to all three banks. Then in effect, we are sharing with them very sensitive data that may affect our market share. Because initially the three banks, they may share this market sector differently. Maybe one of the banks, a major player compared to the other two. But if we were to share all the data, of course, the model performance for each party would see some improvement. But if all using the same data for performing the analysis, same model to perform the analysis, how would this affect their market share? The bank with the larger market share may see a decline in the market share, and they will care about this this part. So there were some considerations from the business perspective we didn't take into account when pushing such technologies. So this could be something interesting to consider.
Okay, thank you. The next question will be the final and signature question for this P-Talk, because APO is a productivity organization. We always ask these questions regarding productivity. So how do you think the responsible AI, ethical AI technologies can enhance productivity, especially experiencing this new normal era?
Okay, sure. This is a very valid question. So whenever we are trying to deploy AI technologies that contain ethical considerations, the first question will always try to convince the business that this kind of thing not only makes society senses, but also makes business senses that can help them improve their productivity. So in order to achieve this goal, currently there's no universal solution. We need to analyze each case by case. Okay? And from our experience, the dimension of explainability and the dimension of fair treatment of users can complement productivity, especially from the efficiency perspective when it comes to incorporating these into AI solutions. Okay? Other parts like privacy preservation, normally they would cause certain extra overhead in terms of both training and deployment of the AI solution. So for those parts, they don't really complement productivity well, but doing so would be under pressure from the regulators' perspective, and the companies would be forced to do this if they wish to operate in certain jurisdictions that promote privacy preservation. Okay, so the different dimensions of responsible AI would interact differently with the productivity dimension, and this would, as we mentioned before, would mostly be a case-by-case analysis situation. Okay.
Thank you. As we're getting to the end of this P-Talk, let me summarize what we have discussed and shared so far. So last year, Singapore released the reference documents, like we learned, which is called AI Ethics and Governance, to apply the technologies responsibly. As Professor Han stated, it includes a holistic framework that covers the actors like stakeholders and other elements like operations management, internal governance, and human centricity, which require the ethical use of AI and building trust among the stakeholders. So Professor Han introduced the technological solutions to help address the common concerns people feel about the widespread of AI, such as like maybe people have such concerns like human treatment in AI and unintended consequences and the control of intelligent systems. And you shared the federated learning to preserve privacy and then PIDS for fair and explainable AI. So that was a good example that could be shared with our member countries. So we hope that Professor Han's presentation serves as an example of how to design and incorporate the AI advances to apply the technologies ethically to benefit as many people as possible. So finally, we can live with the AI technologies that direct us, that lead us to ethical choices, responsible behavior, and transparent business management, as explained in one of the slides, the three dimensions of human ethics. So we wish this P-Talk is promoted in the respective countries in their own languages to deepen the thoughts on how to use and how to set directions of AI advances. So before we finish, could you please give your final message for our viewers? Professor Han.
Okay, thank you very much. Thank you for inviting me today. I hope the talk would stimulate some interesting discussions into this topic. And as a parting message, I really wish to invite participants to try to register for our short course on certification of ethical AI, so that you have a more in-depth treatment on the topic from our team of instructors. Okay, thank you very much.
Thank you. And we've got like some messages, like a good, the messages from the viewers that some of our viewers may want to consult with you for developing their AI solutions for ethical governance. So in that case, maybe we'll try to liaise you with our member countries.
Sure. Thank you very much.
Yes, thank you very much. So thank you very much for your kind message and for today's discussion and presentation. And thank you all for joining this P Talk today. So please stay safe and healthy, everyone, and see you again. Thank you.
Okay, see you.